Hello everyone, this is the mechanics lab motion along an incline. And so we will have a incline like this, elevated by angle theta. So the cart will accelerate downward. Theoretically, this acceleration will be proportional to sine theta. And according to mechanics class, if we make a plot of position time graph, velocity is the first order derivative of the position. That's the slope of the position time graph. Similarly, acceleration is the slope of the velocity time graph. So today we will have a motion detector to detect the motion of this cart that's connected to the LogPro software. And the computer can make a plot of the velocity time graph and also position time graph. And for position, if the motion is with the constant acceleration, and we know that the position and the acceleration follow this relationship. Using the software, we can make a curve fit of the position time graph. And if you compare the coefficient of the second order of t and t, and we can find a relationship between acceleration will be 2 times the coefficient of t squared, 2a. So today, we will measure the acceleration in 2 different methods. For each trial, one is from the slope of the velocity time graph, and another trial is from 2 times the coefficient of the second order term of the position time graph. This is the data I collected. I tried 5 trials, and I measured the height of this incline. This is h, units meter. And the length of the incline is constant for all my trials. And I got, for each height, I got 6 acceleration. And the first row is from the slope of the velocity time graph. And the second row is from the coefficient of the position time graph. So you can analyze this data in your notebook, and the results analysis, you will calculate the average acceleration for each different height, and then calculate the standard deviation. After you found all the acceleration, given the height, and given this length xl, you can calculate sine theta. Sine theta equal to h divided by xl. We have h, we have xl. So you can calculate sine theta for all 5 trials. And after you finish the calculation, make a plot. Y-axis is the average acceleration from this column. And sine theta is calculated by the ratio of these 2 columns. So you make a plot, because we know the acceleration will increase when sine theta increase. So this will be a very good linear line. And the slope of that line, theoretically, it should be the free fall acceleration g. So if after you try linear fit of the plot, slope should be around 9.8. This is the setup we will use. We have an incline, and we have a ruler, meter stick. This side we have a cart, and that's the motion of the cart. And we have a motion detector to detect the motion, and that's connected to the LogPro. This is the computer program we will use, and there are 2 diagrams. One is the position versus time. The other one is the velocity versus time. First, I'm going to measure the height, h, and from here, I'm going to use the number I read here. That's about 22 centimeters. I can find XL by reading the initial position 20 centimeters. Final position 228 centimeters. The difference that will give us the value of XL. To start the motion, I will click collect, and then I will release the cart. Next, I'm going to collect some data. So I have a cart ready to go, and I will click collect and release the cart. Very good. This is the position time graph. This is the velocity time graph. You see this part is pretty linear. And let's highlight a section. Try linear fit. The slope is negative 0.2931 meter per second square. The reason it's negative because it's moving toward the motion detector. So, but in our experiment, you can forget about the negative sign. Therefore, acceleration from the slope of the velocity time graph is given by 0.2931 meter per second square. I can also get one from the position time graph by trying a curve fit. I'm going to try a quadratic function, curve fit and a try fit. Now you had the coefficient in front of t squared, that's a, and a is given by negative 0.1480. So from this plot, the acceleration will be 2 times the value of a, so it will be 0.296. 0.296. That's from the position time graph, and this is here it's a 0.2931. So they are very close. So this is how we collect the data.